Thank you everyone for joining today. My name is Alexis Abedisian. I am the Assistant Director of Events and Special Programs for DSI. I'm really pleased to welcome Nayan Paul to our iCubed seminar this morning. Nayan is the Senior Manager of Data Science Practice from Accenture. He'll be speaking about implementing data products through data mesh. Welcome. Thank you so much.
Thanks so much. Hello, everybody. My name is Nayan Paul, and super excited, happy to come over here and present some of my experiences today. I have two talks today, being the first one, talking about building data products within the construct of a data mesh. And next week, I'm going to talk about building ML products on top of data products. So hopefully we'll have a good outcome today so that I can see a lot of you in the next class. So we'll get started. So skip this. So when I talk about data mesh, it's very important to lay out some ground rules because there are so many topologies. There are so many ways in which you can implement a data mesh. And more importantly, when I have gone to my clients and asking them about what data mesh meant for them, I practically got 6 answers from 5 projects, which means there are guiding principles as what a data mesh should be and could be, but the implementation of a data mesh varies because of the business problem in hand, plus what is the value proposition to the client. So we will set up some ground rules today. First one is we are talking about a data mesh within the construct of a data lake, which means we're not talking about replacing a data mesh or a data lake with a data mesh. It's a logical extension. 2, data mesh is not a technical problem. We're not trying to implement a data mesh because there are some technical limitations of a data lake. And third, we talk about one example today, and that example is based on 2 of the projects that I personally implemented. So what I'm going to do is we're going to talk about some guiding principles. We'll talk about some fundamental jargons, if you may. What is a data asset? So we term data asset as any data set that is within the construct of a data lake. So any data set that is represented in your simple data platform, any data set that is onboarded into your data lake is a data asset. Everything is a data asset. But what is a data product? So data products are specialized data assets that has some characteristics. 1, it should have a business focus. So for example, if I'm onboarding a product data, the product data is a data asset. But the product data is not yet a data product. It can be a data product if somebody asks that question to that data set, asking, oh, how many products we sold last week? And if I'm rolling up that particular data set and asking a very specific question, then eventually that particular data asset has the capability to become a data product. It is shareable, which means if I'm building a data product for myself, it is not really a data product. It is really a data product when I am building something with the intention that somebody else can reuse it. There is a sharing usability associated with the data asset. It holds a single meaning. Like I said, if I'm talking about building customer as a data product, the meaning of customer within the entire organization should. You can also say, there are 2 different data products called customers. It has to have a unique meaning. And it should be able to have cross-domain access, meaning, let's say within the organization, I have sales department and I have marketing department. Any data product that the sales department creates seems shareable with the products, both with the marketing department. There are certain characteristics about the data assets that turn that into a data product. But if you look into all these capabilities, the intention is it is business focused. Something has a meaning, and the meaning is deployed and shared across. Now, there are something about feature sets and feature store. We'll talk about that next week. But again, if you look into it, the feature sets are a combination of data assets, which can also be a data product, but it is mostly used for machine learning purposes. It might not have a business context, The business context can be generated through the machine learning model, but it is mostly about a series, a collection of features which can be collaborated, shared, and utilized. We keep going. So we talked about data mesh. Let's look into a typical data mesh. Now, what does a data mesh look like? So I have an example. I'm talking about the problem statement, why a data mesh exists. So let's say somebody says, oh, I am from sales, and I have to onboard 5 data sets quickly. He goes to the central IT and says, oh, within the organization, you guys are the engineering team. Can you help me onboard these data sets so that I can unlock the value of the data? And he said, no problem, I'll do it for you. Now imagine in a true enterprise, you have sales and finance and marketing. Everybody comes together and says, oh, we need data sets too. Now you have 25 data sets to be onboarded. You go to the central IT and he said, oh, wait, we have to prioritize. We are the central IT team, but we cannot onboard 25 data sets today. We have to wait. And that is a problem. So the business have the money, resources, still, capabilities, but still they cannot onboard their own data. They're reliant on the central IT. And central IT is becoming a bottleneck. So this is the classic case of why a data mesh exists. The data mesh is all about democratizing the data, ability to provide the tools, the technologies, and the skills in the hands of people like sales department and marketing department, so that we can actually own the data and the data pipelines. So in actual practicality, how does it look? So this is an example data mesh within AWS. So this is a data lake that has a boundary. And there are 3 AWS accounts. So logically, there are 3 domains, business domains that are onboarded already into my data lake. So within the AWS data lake, I have a finance team, I have a marketing team, and I have an account. Now, if I'm allowing each one of them onboard the data on their own, very easily the data mesh will become a data mess, right? Because everybody is going to onboard and do their things on their own. So I need to have a centralized governance. So federated access to the data, but a centralized governance. So I can have people like finance teams onboard and build their data pipelines, build their data products, but everything has to be cataloged and registered centrally. So this is a classic example of how I have 3 independent accounts, part of the same data lake, doing their own things, registering things centrally. Now, imagine that I have a 4th team, the sales team. The sales team says, oh, now I have a business requirement too. I need to be onboarded. So they'll come into an ARB or an architecture review board or a governance board. So there's always the gatekeepers of the data lake. They'll come to him and say, we need to be onboarded. Can you onboard us? He said, okay, you get a piece of the data lake. You are onboarded into the data lake. We are giving you flexibility to bring your own data and processes. Come on over. And now the sales team says, okay, I have the capability. I can bring my own data. I can bring my own pipelines. So he starts building his own pipeline. And whatever comes out of that pipeline with a business context gets registered as a data product. So sales team builds a data product, but obviously everything needs to be registered. Those gets registered into the central account. So in my central account, I have a central catalog where people from finance, people from marketing, people from accounting, they can search for the data product and say, okay, this is what I need. So that's what happens. The marketing team says, oh, I think I need some sales information. So you can go and search the central catalog, find out what kind of data assets, what kind of data products are available. Based on the data assets and data products, they can directly go and access based on criteria the data products created by the sales team. So this is a classic example of how do we democratize the entire data lake, keeping the governance centralized. And this is how a typical data mesh would operate within the context. Now, let's go a little deeper. What are the actual challenges with data mesh? So at least there are 6 criteria that would allow us to build a enterprise-driven data mesh. First is the account strategy. Account strategy means how do you have the right demarcation? So basically we talk about separating the risks. So is it okay to build a data mesh where everybody has a single place where everything gets done? So sales department does data in a single place and finance department does data in a single place. Or is it better to divide the entire data mesh data lake into components, logical groupings, like we saw on the previous slide? So the decision on account strategy, how many accounts should we create? Who gets access to what kind of account? If I'm registering a data as a data product from a sales account, only the registered data product should be accessible. But all the other data sets within the sales department should not be accessible to anybody else, right? So the decision on account strategy is important. Decision on security and data classification, which means I'm an HR team. I onboarded my own HR data. I'm building my data products. Can I now enable and open up the salary information to anybody else? Possibly not, because salary will be a very confidential PII. So what are the decisions on security and classification policies within the same data lake is critical. Decision on chargeback. I build an amazing data product and I'm sharing the data product with everybody else. Everybody else is using my data product. Does it mean that I have to pay the bills for people using my data product? Obviously no, right? So chargeback becomes critical. How do I democratize the data? At the same time, differentiate between my storage, the data that I have kept, and the compute that others should use. The separation of storage. Decision on data sharing and access control. So it's possible that I share my HR data without sharing the salary column. So can I share my data set selectively? I can share my data in a certain way with the finance team, and I can share the same data product in a different way with a sales team. So I should have the control to not only publish my data product, but also decide how should I be able to allow people access my data product and what part of the data product they can access. Decision on ownership, very critical. When I'm talking about building a data product, it has to be a real product. Right? When I'm saying that I have published a data product, it only means that people have to give it the right productized treatment. It has to have the SLAs, it has to have the right ownership, and if something goes wrong, it has to have the right kind of accountability. And then the more important thing is how do we implement the data lake technically? And today we'll focus a little bit more on the technical implementation part. Now, this is a classic case. Why is building data pipelines tricky? Why are we thinking about centralized IT? Why IT is becoming a bottleneck? What is stopping us from providing all the tools and capabilities to, for example, the finance? Why it is so hard that till now, without the data mesh, it was very difficult for people to build those data pipelines. So let's look at a typical example of a data pipeline. So imagine that you are given 2 data sets, a product data that you need to onboard from SFTP, and let's say an order data that you need to onboard from RDBs. And the business comes with a question says, oh, you need to combine the product data and the order data. And my intention is to create a report that allows me to understand what products were ordered more this month, right? So you know your source, you know that your data has come from 2 different sources, and you know that at the end you need to create a table which gives you a weekly understanding of which products are sold the most. So what do? You build data pipelines. So typical data pipeline will be, I copy the data into a raw zone, I apply rules to the data for standardization, enrichment, and augmentation of the data. I then perform data validation and data quality. I identify incorrect records. I distract all those records, I quarantine those records, and then I perform some kind of a source to target mapping. Source target mapping is important because sometimes you might get data sets that have a different kind of column names per se, and you want to standardize the common given data that you have. Then you apply some reconciliation to ensure that if you are loading 1 million records, you're getting 1 million records, and no records are lost in transit. We talk about slowly changing dimensions in terms of, I have a customer data or the product data, and the product price is changing. What do you do? How do you ensure that you are getting the right product price propagated for the right kind of decision? Match and merge. So sometimes you might not have a real primary key. You want to match and merge data based on certain combinations, probabilistic mapping. And then saving the data into a single source of truth, number 9. And once you save the data into a single source of truth, you need to back up all of this information into a central catalog. So your steps 1 to 10 is a repeatable, automated pipeline that requires a lot of data engineering. And you do the same for the red one, right? So you talk about building a data process, onboarding the data to all these hoops. So this becomes a little bit of a challenge. Finance team, even though they have the right kind of money and intention, they might not have the right kind of skills, which is needed to build complex, repeatable data pipeline. And why is that so complex? Because here we're talking about an example. In real life, we're talking about 400 pipelines. We're talking about 1,000 pipelines. You need to have these processes enabled for every single data pipeline that you onboard. And once you have the data in step number 9, which is a single source of truth, then you apply your business definition. Then you say, yeah, I can join the data, and I can join it and aggregate it for a weekly status, and then publish the outcome as a table. And whatever you publish as an outcome in step number 11 to 13 is that data product. So you need to have a data engineering pipeline, load the data, get the data into a consumable format, and then you have to apply your business policies to convert your actual data into a data product that is needed. And that becomes a little difficult and a little cumbersome process for non-IT till now. And that is why data mesh or democratizing data pipelines have become a really challenge.
Sorry. So what does self-healing mean in this context? Is it just a technical statement about if the SFTP fails or whatever, or is it?
So self-healing in the sense, for example, I have some data that comes in, and that data, because it is so long, it can actually shut down the pipeline. And if the pipeline fails, then all the data that is supposed to come after that is also stopped. So self-healing means I understand what can cause a problem. I can remediate this problem either through some kind of rules or some kind of data quality checks, some kind of gatekeeper, so that I identify incorrect records. Instead of propagating it ahead, I put it into a quarantine. And I allow the next set of data to pass through free. Otherwise, because of one single particular data set, the others will be just stopped. Right? I have nothing to do, my data is waiting, and my SLAs are now not being met. Now, in a realistic world, we can go to our business domains and talk about democratizing everything. You can say, hey, till now, you have been doing it through a centralizing. Starting today, let's democratize it. And it is easier said than done, mostly because the majority of these business organizations within the enterprise, right? A sales department might not have the right kind of skills and money like a finance department, right? So it is practically not possible to wake up one fine day and decide that you need to convert your entire enterprise into a data mesh strategy, or convert your topology to a data mesh instead of the data lake-driven solution. So this is a simple example of how we have been educating our client and giving them a roadmap. We are saying the journey to being a decentralized, federated data mesh solution is a journey. And the journey has a series of steps. And it starts by having a hybrid mesh to a fully owned mesh. So what do we mean by that? So typical example of a data lake is you have some ingestion jobs that populate a bronze zone. You have some curation jobs that cleans up your data and populates a silver zone. And you have some ETL jobs that populates your gold zone. Now, in a typical organization, you say a lot. So again, going back to what I said, right? So step number 1 to 10 was engineering heavy. Steps 11, 12, 13 was business heavy. Once you enable your data, building the data product, once your data is ready, relatively easy. So we are saying all the engineering heavy capability can still be run by centralized, the blue area at the top. And then the 9, 10, 11, which is more business focused, we can offload those responsibilities to the hands of the business, right? So this is a hybrid mesh. We are saying, oh, we are not just taking away and putting central IT to a corner. No, not yet. What we are doing is we are sharing the responsibilities. We're talking about enabling our data, our central IT with tools and technology so that they can onboard this process faster and then hand it over to business. And our business is not dependent. They can build data products because they have full access to the data. But eventually, we want to go into a situation where we want to start the entire process where all of the data and the data engineering pipelines are actually owned by the business domain. And the data product creation is also owned by the business domain. And the IT plays the governance and security capability only. So we want to ensure that there is a full democratization eventually. Right. So again, we'll talk about the hybrid mesh, how we are realizing this for our clients. So this is the pipeline we saw, right? Engineering heavy pipeline and your business products. So what you can do is you can split it up between two and say, okay, I'll split it between two. I'll have a lot of the engineering capability front-loaded and enabled by the central IT, and I'll have the business outcomes to be a little bit more managed by the business unit. In between, because of us creating the centralized metadata governance process, will ensure that the actual domain owners have full access to the data with security and guardrails. And we'll talk about they can build and publish their own data products. And once they publish the data products, it can also be consumed by another business domain to create another data product and so forth. And this becomes a repeatable, reusable, and fully federated solution of the data mesh. So with this, what I will do is I'll do a quick demo of one of the assets that we have and how we build the entire pipeline, and then we'll get some questions. So this is an asset that we have built. This asset is actually built out of open source Spark, right? And we've been using Spark very, extensively for all our solutions to all our clients, right? So we're talking about building pipelines that can handle terabytes of data, loads. We're talking about, putting these data pipelines into the big retailers and the big pharmaceuticals of the world. So this is a portal, or this is the engineering backbone of how do you create this data products. So if you remember the steps 1 to 10, so what we do is we'll onboard data as a batch, and you just build a pipeline.
I'm sorry, so the target user for this is the data scientist that's on the business team?
Data scientists, data engineers, ML engineers, right? So now we are democratizing, we're saying, oh, building this data pipeline doesn't have to be that engineering heavy.
Okay.
You can build complex data pipelines with the same 10 steps easily using a visual interface, which runs Spark behind the scene and allows you to onboard like terabytes of data quite easily. So again, we'll split it into different parts. How do I onboard the data, steps 1 to 10, and how do I build the data products, steps 10, 11, 12. So this is where you onboard your data by defining where your data can come from. So the data can come from S3, or data can come from SFTP or RDBMS, whatever you have, right? And then we have a series of rules. I'll not talk about that too much. I'll talk about the steps 11, 12, 13. But again, there's a rules engine, and in the rules engine there are all possible kinds of rules. There's some AI-driven rules, and things which allow you to auto-correct data. We talked about the self-healing, right? So if you have something that is wrong, you can auto-correct the data. You can identify, things which are not running properly. You can either discard them or you can try to fix them. There are metadata which will sync up. There are data quality rules, again, a series of data quality rules that you can enable to ensure that your data is rightly propagated. There are some filtering and mapping rules, custom rules, and eventually a data destination rule, right? So long story short, this is steps 1 to 10, which will allow you to actually onboard the data. But the important thing I want to talk about is building the data product. So this is where I go in and I say, okay, I have gone through the cycle of bringing the data, all this 200, 400 pipelines. Now I want to actually go and start building the data product. So as a part of building the data product, I can come in here and I can start actually onboarding, loading the data that I've onboarded as a part of steps 1 to 10 and build this entire data product. But before that, what I'll do is I like to understand what data assets are available. So I go in and so I talked about everything is managed centrally, right? So I go into the data assets and say, I want to see all the data assets that are in my organization. So this API will take a little while. And when you say, show me the details, these are the data sets that we have already onboarded. And I just wanted to talk about the importance of central governance, because every single data pipeline that you created, because every single data product data asset that you onboarded, it has to be centrally registered with a central governance of a catalog. You have the luxury here to come in and understand who owns the data, where the data is located, what kind of business domain, business ownership schema data is available, what kind of data quality information is contained within the data. So all the reports about the data quality. What kind of metadata information is available. So you can define all of that. So just by building a repeatable, reusable pipeline, now we can go ahead and start getting a lot of information about the data asset. Now, as a data scientist, data engineer, I've come into the data asset gallery. I can understand from the metadata capture all possible data assets that are available. And I go back and say, okay, now I need to go and build my data product. So you come in here and you say, I want to read a couple of data sets. I want to read a table, a data asset. I can read another data set, which is lying in my S3. I can apply some business logic, like deduping something, applying some filters, and a bunch of other things. I can provide some kind of functional requirements. So I can write my own function, or I can actually bring in some of the assets that are pre-created. And finally, I can join the data sets, for example. And write out the output. And say, this is my final data product. So it's still not a data product. It's still something that I've written. So what I have to do is I have to go back and say, I want to register this as a data product. What does registering as a data product mean? Right? So registering as a data product means you need to fill in a data contract form. You have to define what is the business case, what is the business domain, what is the ownership, where is the data located, what are the policies, is the data public, private, what kind of PII tags are there. If you define all of this and register, then you come in here. Once it is registered, you go into the data mesh and look into the data product that gets registered. You open up this data product and you can look into all the details about the data product. So this is an example of how we can bring in data from all different sources, use open source Spark, build this complex data engineering pipeline, steps 1 to 10, come in and discover the data through a central catalog, look into all the data sets that are lying in my data set, and then loading those data into a business outcome, and finally registering the business outcome as a data product so that not only me, but others can access it. And again, you can tag it with public or private so that, if you're opening it up to public, every other organization units can access it. If not, then they have to go through a security and access control. So this is where I'll stop. I'll take some questions.
How much of a customization is possible given a certain like production to this?
Very much, right? Because no two data lakes are similar. No two data mesh are similar, right? So that's why, at least from an Accenture point of view, when we go and talk to our clients, we understand that. We talk about bringing jumpstart kits. Solutions like these are jumpstart kits. It will help you achieve 30, 40, 50% of the client's aspiration, but the remaining 50% have to be implemented as a part of the client engagement.
I see this has some similarity with the internet solution. Which is say there's some appreciation that it's significant from the spirit of the internet solution.
Yeah. So, right. So again, so our intention was when, and again, I was talking to you right a little while ago. So when you go and work and try to solve something for the customers, it's important that we are not building something totally. So when I say Spark, the underlying common denominator for Databricks, Azure, GCP, AWS is Spark. AWS View is Spark. AWS EMR is Spark. Databricks is Spark. GCP Data is Spark. So in underlying, we have the capability where whatever, actually I'll show you, right? It's actually a code generator. You come in here and you say, I want to see the preview. So everything that you've created, it creates a configuration file, and the configuration file is actually deployed based on what you choose. So you can choose to save it as a glue job.
So you scroll down like a little bit. I was in the card page. Oh, yeah.
So this is where if you are going to an AWS point and they're saying, oh, we are an AWS shop, and Glue provides you that serverless capability, Spark serverless. Then instead of actually writing something by hand, you can democratize, right? As a the sales department or HR department where they might not be engineering heavy, it becomes an easy way to create your blue job, right? And think about 200 blue jobs. Think about 500 blue jobs. It's all these 10 things, right? So it becomes very easy for them, right? This is one way of democratizing knowledge.
So can you run version control over this text then? So
Yeah. So when you save it, it actually automatically gives the version and everything else. So one good thing about it is, like you pointed out, imagine that I have developed something in dev environment and I want to move it to QA. In actual reality, what you are moving to QA, we're not moving the code to QA because the code has not changed. We are moving the config file to QA. It becomes very easy, right? So development is not only easy, your management, maintenance, support, running support, everything becomes easy. So this is one example. This was something that we patented 2 years ago, where you have the ability to now create 200 new jobs or 200 EMR jobs, 200 Databricks jobs, underlying some Spark, but more democratized way, more visual way, with all the right guardrails and controls around it. Any other question?
With regards to like access security, who decides which columns are accessible to the other departments?
Good question. Let me see if I can answer you a little more visually. You might have an example. Here's some example data that I have. So one capability that we have is called data grooming. Right? So typically you would groom data. When you onboard data, before onboarding you need to groom the data. And grooming can be as simple as profiling the data and eyeballing the data. And that's grooming too. But typically, as a grooming process, you need to do a few more things. You need to define the sensitivity. And if there are some tags in the list, and if there's some business logic. Right? So there are two ways of doing this. One is a lot of technical metadata can be scanned from the data itself. So internally, we will have scanners, PIL scanners to scan, and those scanners are based on NLP library, which are based on regular expressions that allow us to actually go and tag those columns and say, oh, this column is an SSM column, this column is an email column. But then what is PII for the organization? that list would definitely come from somebody, something like a CISO organization. Your security and legal organization, legal department within the organization, they typically will have a list as what column or combination of columns is the PII for that organization. Right? So technically, you can scan and tag, and based on the tags, you can create these tag-based access policies. In AWS, you have something called link permission. So you can actually, if you have the tags ready, your program can scan the tags, but you can actually use the tags and provide role-based access control on that column. So that if somebody selects select star from the table, internally, the only give him an output is select star minus those PI accounts to the account. So everything has to be, in single language. So this is one way where you can scan the data and automatically tag, but it is also possible that you can search before. But as a business user, I might know the business document. So business document is one example where it's very difficult for any algorithm to go and auto-populate business document. This is something you can populate, you can search it here. It always has to be a combination of technology and human beings together to create something that is more also secure.
You mentioned about this solution of the data mesh for inter teams, right? Let's say from business and engineering. Is this something applicable for intra teams as well? Because sometimes there could be situations where there interact, there could be situations of evolving out of this. So would this be applicable in that situation?
Absolutely. Now, how much granular you want to define if it is organizational based? And some organizations might say, and we have seen that too, right? Within the organization, we'll say, oh, my HR data scientist should have different kind of access, and my HR data engineering team should have different kind of access, right? Now, do you really need to build a mesh around it, or can you save, or can you solve a lot of this problem using role and tag-based access control? So it's a I would say, fine line. We work with the business, talk to them, and understand, because a mesh means something that I'm releasing as a product. And not only releasing as a product, and maintaining as a product. Now, if I have an intra department, do I need to maintain something as a product for another team to use? Right. So I can just give them a different kind of an access and say, I'm not going to give this particular data as a product like treatment. I can give it a normal treatment. So those are fine lines.
Take an additional overhead to
Yeah. Like unless, for example, you are part of the team and somebody says, oh, you have to give it a product like treatment, which means at 2 o'clock in the morning, something goes wrong, I can call it, right? And because you have to give that the same one treatment.
If you don't mind sharing, could you share a expected timeline for this entire things to be built out?
I mean, some of the projects we have built it out in 6 months and less. Because when I talk about building out something, it's data ops and DevOps and DevSecOps, right? So this is data ops, data engineering focus, building the data, building the pipeline, bringing the data, ensuring the data is in the right place. And then there is DevOps, it is more about the platform, the securities, the code promotions. And then there is DevSecOps, right? All the CISOs, all my internal, what kind of keys are being used, what kind of encryptions are being used, right? So it's a combination. From an engineering perspective, we have implemented something like this in 6 months or less. Any other questions? Sure.
Yeah, you mentioned earlier that there is an initial stage where the central IT is still kind of in charge of everything, and then you transition to more decentralized, like allowing the users to own the data and manage the data. When would you say it's the company is ready to make this transition? And also, like, what kind of changes are required after the transition? Because you probably need more like data engineers in each sub-department to like manage the data and everything. So how does that look like?
So the biggest thing is the mindset shift, or an organizational mindset shift. To be very honest, I don't think there is any organization till today that has completely transitioned into a fully automated data mesh. Because the maturity within the organization matters, but the maturity inside the organization, like my sales department maturity versus my finance department maturity, that also matters. I can say, hey, I can be totally hands off, but centralized can be totally hands off. But the finance department might say, yes, we are okay with that. We have the skills and the resources and the money. But something like a small department like accounting, we might say, oh, we are not ready. We still need more hand holding. So that transition that's why hybrid is so important, right? I mean, you cannot just one finally say it's done, right? Because you need to ensure that everybody is listening to. So that transition, honestly, I'm not seeing anybody making that transition. Everybody's in that journey. And different parts of the journey, but everybody is in the journey. What we have seen is, like I said, I was giving an example, right? Like within the data, there are 3 different teams and sales teams. If you saw that, right? So that is critical. We have built data lakes where there are 9 different AWS accounts involved. Right? So we are actually dividing and bifurcating and providing the right separation of concerns to each of the teams, so that we can be more, self-sufficient to a certain extent. But then, even then, to a large extent, these 9 accounts are maintained by centralized. So even though we were saying that, okay, we are giving you a fully automated access, you have your own capability, you can build your own processes in that account. But in all reality, that account is also maintained by centralized, which is also a good step, because now you're ensuring that your finance team is not coming to your account. You have all your highly confidential restricted sales data in your sales account, but the maintenance and management of the account is still somewhere I can see. Any more questions? Do we have any questions from the audience?
How disparate do you find that data sources are, and how big of an issue is even capturing the data into something that's just coherent?
Well, very honestly speaking, right? This has been one of the ingestion and management of the data, like on the set 1 to 10. When I say ingestion, we talk about 1 to 10, right? Getting the data in a stage where people are consuming it. This has become important. That's where I was talking about when we started talking about how to use the data products for building the ML solutions. Getting the data product in my experience, we have been using enterprise data warehouse a lot, right? People have been using data warehouses for a long time. And a lot of the logic is in the data warehouse, a lot of data is in the data warehouse. And I believe when you go and talk about modernizing the platform, talking about being in the cloud, you cannot just go and source your data from here. You cannot go and get your data from data warehouses. You have to go to your source of truth, go to your SORs. And that might be a third-party data. It might be data that of all different formats, kinds, whatnot. And not only the data, the logic that has gone into your enterprise data warehouse, that logic is 10 years old. People have been working 10 years on the system, running package after package after package. So moving the data is one big thing, and converting all the business logic, translating those into your modern cloud platform is another thing. In combination of that becomes very critical and critical.
I'm just curious about the applications. Can you give an example of like why one department in a company will require a data product from another department?
Yeah. So a classic example is, let's say, customer. So let's say your marketing team needs a churn report, right? I'm a big organization. For some reason, I'm losing a lot of my customers to my competition. And I want to understand who are those people who are trying, and can I do something to stop that? So one of the important things I need for building that kind of churn report is the definition of my customer. Who is the customer? And typically, those kind of information might not be available as a marketing team. That might be available with an HR. Right? So HR team can have a data product that defines what a customer is. And a customer can be a combination of 200 attributes. There's demographic information, there's maybe some kind of background information about where he works, the salary, his social media information, right? So what a customer is, that if that is the bill, you can think about at least, in my head, 20 different data sources that we need to collaborate with. The demographic information has to come from one source. The social media can come from 5 different sources. So I have to do a lot of engineering work to get that customer data, located and build out as a product. And if finance team has already done that work, why do I have to spend 6 more months building it just for getting an answer to a question like who's churning? Right? So as a marketing team, it's easier for me if something is available as a product to go and get the data and use it for my business decision.
Sorry, I'm just the data set. I work with the data science institute, and we have some typical questions that we like to ask our speakers. And so it would be great to ask you. What brought you to this work? It would be great to hear a little bit about your personal career and how you ended up in this place, and let us know what kind of trajectory exists possibility for our students. Yes.
Sure. So again, I was actually pre-2012. I was mostly focusing on being a developer. I was doing a lot of Java programming. I was lost into building mobile applications. And I think there was a lecture from MIT, and they came down to my university. Not university, I think that was one of those sessions. They talked about big data analytics in those 2012, and it was pretty fascinating. And those days, I still remember, there was a lot of requirement of Java developers to be in Hadoop because Hadoop was written in Java and all. So there was a huge drive. I was in India at that point in time, and they opened up a new COE for Hadoop, like big data. And I think that's when my journey started. I slowly got very interested. New problems, something which was not available, and you cannot browse and solve problems. And I think that was a starting point. And then, AWS came in, and there was cloud transition, cloud migration. Since 2012 to almost 2015, 2017, I was doing a lot of cloud work, cloud and data work. And over a period of time, everybody was getting their cloud readiness, right? And then eventually, people started asking, how do I get the benefit out of the cloud? You talked about building data lakes on cloud. I've done that. Now what? How do I get my money out of it? And that's where the data science piece came in. So a lot of people are talking about using data science as a return of investment from the data that we have procured. I think that was a new avenue for me today. I started enrolling myself into a lot of courses. I talked to my mentors in my organization. I realigned myself to be the data science and MLOps directly. And over a period of time, I think most of my learning has come from my active, client missions. I've been going to the client, understanding the actual problem and trying to correlate what I've learned in theory to what the actual client needs. And that has actually driven me towards where I am and what I've been doing.
Great to hear. So another question that we like to ask our guests is for our students or MSDS students or anybody who's interested in a career in data science or data science oriented, what is the takeaway that you encourage them to leave this program with? One skill set, even if it's software or technical, that you really encourage, would like to emphasize, leave this place having this under your belt.
I think the most important thing is being a problem solver. Technologies will change. In my small career, I've seen so many transitions of technology, and I can guarantee in the next 5 years things will change again, right? You cannot run. You should be technically very savvy, which obviously you guys are because you guys are here. So you cannot leave technology, but you have to be a problem solver. You will have different kinds of problems. Try to think about the problem, and then think, oh, how do I solve the problem with what I know or what I have to learn? So I think the problem-solving mindset is very important. At least that has been something that I focus on. And then technology can fit into the problem-solving. So if we can nurture that, that would be fantastic. Yeah.
And what kind of person would make an ideal candidate to join your team at Accenture?
My team would be somebody who is self-motivated. I run a small practice, I run 2 practices in Accenture. And from those practices, I actually build products. So this is one product. So we have a very small team, really, and I keep on telling to my, managing directors that we have to have the culture of being a startup within Accenture, right? Because in big organizations, it's very easy to have too much of that age. So for my team, it's absolutely important that you are quick learner 1, and 2 is self-motivated. If you can take the responsibility on your own, get the things done, then I think that's the best thing anybody can ask for.
Thank you for the response. I think you were done with the slides.
I'm done.
Yes. So we just want to thank you so much for coming in to speak to us today. I know you're going to be back. We're really excited for the second talk, and we want to thank you for everything. And we just want to give you a round of applause. Thank you. We're getting thank yous from the from the chat, and we look forward to engaging with you.
Same here.
Thank you.